Hello, can you hear me?
We can indeed. I believe you are the second New Zealander we have speaking today, so it's good that we're getting across the ocean and the kangaroos are not drowning. Now, I mentioned your talk earlier when we were talking about Optus, and this. So this was a blog post, right? This is a blog post you wrote, and
this
then
was originally a blog post for COSIV when I was still working there.
Yeah.
And then I sort of spun it into a talk, and this is, I think, actually the third time I'm presenting it, but yeah.
Yeah. So I think we were really interested to hear it because I think a lot of people hadn't really heard of API security before Optus, and then it became this big thing, and then we're like, oh, what is this? So yeah, we're really keen to hear your talk, and we will let you start talking.
All right. Okay. Thank you. Oh, let me just see. Okay, cool. That does actually work. Oh, bum, Damn. This is supposed to have a bunch of Simpsons GIFs or GIFs, but they're not animating. Damn. Oh well. Yes, so hello everyone. My name is James Cooper, and so yeah, this talk is about securing REST API endpoints against data leaks, or how to avoid another Optus, and I'll talk about it briefly in a moment. So I am a security interested software developer these days. I have had different roles in the past. These days I currently work as an application developer at 2 Degrees, which is a New Zealand-based telecom company. I wasn't actually working there at the time that the Optus thing happened, but I am now, coincidentally. I have a PhD in computer science and some other degrees from the University of Auckland. I'm fairly active on the InfoSec Discord, and I'm in the ComfyCon Discord. That's probably what's for today. So what I'm going to say is that the focus today I'm talking about is just on REST APIs and preventing leaking sensitive information out of them. So sort of quite a narrow focus here. I'm not talking about gRPC or GraphQL, say, most because I don't have any real significant experience with them. I'm pretty sure a lot of what I say here is going to be same for that. And of course, to be clear, when I say the sensitive information, I mean, customer, employee, personal identifiable information, that sort of thing. Another point I want to make is that I assume that you have to keep whatever data that you're storing if you don't actually have to keep it for some good reason. So, like there's some proper legal reason or some actual business reason that you have to keep it. If you don't have that, just get rid of it. Anything you don't actually need to keep, get rid of it. Bruce and I called data toxic at some point, and I tend to agree. If you haven't got the data, you're not going to leak it. Another thing I want to point out is that what I'm talking about today, it's none of these things I'm going to say are new to me in the slightest. I was just pretty much compiling information I've heard elsewhere. It's also not exhaustive, of course. So see things like the LWASP API top 10, which I think they just came out with another one last year, and probably various blog posts around the internet and everything for lots more on all this topic. And lastly, I want to emphasize, especially since I now work for Telco myself, talk isn't actually a dig at Optus. Basically, it's saying, okay, this thing happened, and I have a suspicion of why it might have happened. Let's all try to learn from that and make sure it doesn't happen to us in the future. Was the idea, right? So we'll wrap up about Optus just in case someone missed it. So back in September 2022, news came out that someone is doing to store Optus, which I'm assuming everybody online here actually knows about. Just a big telecoms company operating in Australia. Oh darn, hasn't worked properly. The dark web part's supposed to be in red and all spooky looking. But basically, someone was on the dark web trying to extort Optus because they had all this data. Suppose they had 10 million records, they claimed, which is about 40% of the entirety of Australia's population at the time, and they leaked 10,000 subset record as proof. And so I think about a week after this all came out, well, shortly thereafter, the Optus CEO at the time came out and said, "Oh, well, this is a very sophisticated cyber attack," the usual sort of line. And then about a week later on TV, after this all been going on, the Minister for Home Affairs, Claire O'Neill, who I'm assuming most Australians know better than I do, and I think she's still the current minister for that, was asked on TV interview, essentially, "Oh, you don't seem to agree that this was a sophisticated attack." And the minister just said, "Well, it wasn't, so no." Just outright, blatantly said that, which is pretty much as close as you're going to get to a minister openly slagging someone off and calling them dishonest and incompetent. Apparently what had actually happened was that this attacker had found an API endpoint returning real customer data with no authentication requirements whatsoever. So that was how they got it, and which of course is not a sophisticated attack, it's pretty much the direct opposite. So in the end, I've just actually got a bit luckier for all this. there's a lot of media focus and government focus happening, and the person who did this took down the records that they had posted, this 10,000 record subset, and kind of sort of apologized for it and said, oh no, I'm going to take it down now. And they said, well, there's no security.txt file, so I can't report the vulnerability. And therefore I went and scraped it all and tried to extort people, because one obviously leads to the other. And then about probably another week later, the Medibank breach happened, which was a lot worse really, and took the focus away from the Optus thing. But in the meantime, the reputational damage, ministers publicly disparaging them, and credit monitoring officers, mandatory credit monitoring officers. I think there was some talk of them having to pay to get driver's licenses reissued, but it might have been Medibank, I can't remember for sure. Anyway, all of it was probably very expensive for Optus, and this incident combined with another one about a year later, so about November last year, which was not a cyber thing, but another incident for Optus, pretty much led to the CEO basically having to quit, because they were not very well regarded anymore. So I have some thoughts on how did this happen, and I have no inside knowledge on this topic, but my best guess is that probably, well, my best guess at the time, I'll come back to this later, was that somebody had turned off authentication for a particular endpoint that involved customer data, or they were testing it out and then forgot to turn that authentication requirement back on. And to me, that suggests that there's some sort of structural, organizational, whatever issue, and that, yes, one person can turn it off, but it should have been much more difficult than, like, it shouldn't really be feasible for one person to be able to do that and have it go all the way into production and stay there. It suggests to me that there's probably some sort of, they didn't have a relevant policy or procedure or process, or it wasn't being enforced. And if you don't enforce it, basically, you might as well not have it. And so the point was, one developer has one bad day when they forget something, and there you go, that's many more bad days for everybody. Oh, wow, and the slides really are stuffed up. Right. So the other point I want to make is not that you shouldn't sit around playing the blame game. I've heard it called blame storming before as well, which is an issue itself. What you can get people saying, oh, well, it was Joe's fault because he didn't do X, and oh, no, it was, this department's fault. It's because they didn't do their job right, sort of thing. Basically, it shouldn't be really feasible for one person to make all the mistakes. That to me implies if there's more, if it takes one person can achieve it by themselves inadvertently, that implies to me that there's broader organizational problems. And overall, pretty much when you're looking at what's happened here and these sorts of things, you don't sit around trying to find someone to blame. You try to figure out what the problem was and how to avoid it in the future. I mean, yes, if you've got big flashing signs saying don't do this thing, this is bad, you're going to make problems if you do it, and they did it anyway, that's one thing, but that's probably not what happened. So instead of sitting around trying to find the intern to blame, just figure out what went wrong and try to fix it for next time. Right, so we get to the sort of heart of this talk, which is a quick discussion of some different techniques you can use to try to prevent this happening from you in the future. And a point out now is that some of these techniques are technical ones and others are more cultural, organizational ones. So they kind of involve different people implementing them, as it were. And so the first thing is to deny by default. So this is basically all requests to API endpoints, unless people have got all the authentication stuff exactly right, just say no. Basically, don't let them in. Just deny all requests. And so it means two things: that any unauthenticated access gets told no. You don't say, oh well, you're not authenticated. We'll just give you the data anyway. Which hopefully is pretty obvious. But the other thing being that in the actual software code itself, you have it that all unauthenticated access must be explicitly marked somewhere as being unauthenticated. And so I know in Django and ASP.NET Core, you actually have on your API endpoint definitions a little tag saying, okay, this one's, people can be access this one anonymously without being logged in. And so you want it to be that you have to put that on for people to be able to use it without being logged in. In fact, ideally, you have it that if you haven't got any sort of tagging, absolutely nobody of any type can get it to it. And so that would mean that basically what happens is, if it goes out with no tagging on it, then when someone rings you up, or like goes out like that, then what happens is your customers, they try to access your API and that doesn't work. And then they ring you up that day and say, hey, this thing isn't working. You're just getting lots of 401 back. and you get it fixed that day and everything goes on happily. Or if you do it the other way, it's you're missing the tag. Someone comes along, scrape pulls it out, and a few months later, big issues. So basically, you just take the approach that people have to. If they don't actively say it should be open access, it is closed access. And of course, the other thing being that if people, for any endpoint whatsoever, whether it exists or not, if people aren't authenticated, they get back a 401 response rather than a 404, say, because that way they stops someone from being able to map out your attack surface just from status codes. Obviously, for something like a login endpoint or a password reset, you need to make it different, but that's one of the few that are explicitly made anonymous, allowed ones. This is all called fail secure. And so because this one thing is so strong and so useful, I'm going to re-emphasize deny by default. If you remember one thing, make it that, because it stops the vast majority of the unsophisticated attacks, and it makes life more difficult for the more sophisticated attackers. And for the most part, in most scenarios, they're not targeting you specifically. They're just looking for a victim. And if you're too difficult, they're going to go somewhere else because they're going to say, this one's just not worth it for the amount of time and effort we have to put in. Maybe we won't even get there. Basically, if you're too hard to crack, they'll go elsewhere. And just using deny by default makes you so much harder to crack, especially if all they ever get from checking in your endpoints is just for a 1 out of 10 go away, then it's not really much they can learn. Right, so the next thing I'm going to say is I'm going to talk about code reviews. And so hopefully anywhere that's actually developing software that's more than one person doing it, there'll be a case of, well, duh, of course we do code reviews. But of course, the point being that it's very easy when you're one developer working on something that you forget to go back and fill some part in or what have you. Whereas the reviewer should be able to spot it. And especially if you have these exposed endpoints that allow anonymous users, well, your reviewer should look at those and say, okay, well, what's up with that? And so if you've got the deny by default where they have to put the attribute onto it to say anonymous users are allowed, then it becomes very obvious to the reviewers this is anonymous, and they can say, well, why is that? That doesn't make sense to me. And of course, the point to note about all this is that you want to try to ensure that your reviewers do actually understand the broader context of what they're reviewing, because of course it's awfully easy for a change in one place to suddenly alter an assumption that was made somewhere else, and you have this weird flow-through effect where a change in one place ends up having some weird unintended consequence in another place, and sometimes there's just no way that anyone can know that unless they happen to know the code base pretty well. So you want to try to make sure that you have people who are going to know the effects of the changes. Not always possible, but if you can, do it. And lastly, make sure that for deploying to production, people have to have got reviewer approvals, that they're absolutely mandatory. And so GitHub has a feature called Protected Branches, which does that. There's another one, I think GitLab and Bitbucket, I think it has something similar, I'm not sure what it's called. But basically the idea for all of them is that if you haven't got enough reviews on merge requests, then it doesn't get merged into the production branch. Right. Another one I'm going to say is to ban changes in production. Now, this is probably going to sound slightly weird at first, but what I mean is, someone just like SSHing into the live box and just changing a code file there or twiddling a setting here or something like that. And you just shouldn't not do that. There's a few reasons. So first of all, it gets around that code review and approval process that we just said is a good thing. You really want to have continuous integration and continuous deployment so that people make changes in code and then it all gets automatically, once it's merged, it all gets automatically deployed for them. And you only deploy to production from those protected branches that someone can't just quickly make a change on their own and send it out, because it's not a great idea. And so some of the reasons this is a problem is that when someone does fix something in production, if they've just logged into the remote box, there might be, 7 o'clock on a Friday, they finally fix the problem. They say, okay, well, I need to go update the, actual code for next time to get that fixed. But of course, they've just fixed it in production, so they go home and by Monday, forgotten all about it. Or the other problem being that they make some sort of temporary change for whatever reason. Maybe they're experimenting, maybe it's just to let some stuff go through to take some pressure off somewhere, whatever. And it's just supposed to be a temporary thing. But again, they get distracted, something else happens, and they forget to go back and fix it later on. And, that can end up sitting around in production for a while. And of course, especially if someone starts making changes where they just open up lower authorization requirements and something at some point in time, there's actually no guarantee that someone isn't just going to have come along and happen to look right at that moment when it's changed, even if it's only temporary thing. So just don't do it. It's pretty bad. Another thing you can try, which is a little bit less strong, it's more of a supporting thing to the others, is so to go along with your pre-existing software testing. So you've already, presumably everyone, I presume, has got unit tests and integration tests and end-to-end tests. Another thing you can add to that, in whichever way you want, is to do this thing called control validation testing, which I just call automated exposure testing. Basically, you just have some system go through and send just basic requests to your API endpoints. And so, all unauthenticated requests should get back a 401, all authenticated but without the right level of authorization should get back a 403, all appropriate requests should get back like a 200 or a 201 or whatever. Just as simple as that. And that can mean that if you've got one which has suddenly somehow gone from being authorization required to anyone allowed in, as long as you know the baseline you're expecting, you can have just this automated tool say, hang on, wait, this one suddenly changed. It's now letting anyone in when it shouldn't. And so that can be useful just to help you keep tabs on what's going on. And I mean, there are lots and lots of tools that can do this. You've got various DAST things. I'm pretty sure Postman and Insomnia and Bruno support it. And I'm pretty sure you could create your own just using curl and a shell script if you wanted. It probably wouldn't be a great ending point, but I'm pretty sure it'd be a good starting point. And you can also consider doing this sort of thing in production as well, but just make sure you do it carefully so that you don't potentially DDoS yourself or DOS yourself in production, but also, of course, that if you've got a security team and they're watching and suddenly there's all these weird requests coming through, that you'll make sure that they know what's going on so that they're not saying, well, someone's trying to attack us. So it's a good idea to try it in production just in case, but be careful about it. And the last one I'm going to talk about today, which is hiding behind Brasshead partly, is getting security training for developers. So lots of developers these days are self-taught. Even people with ComfyCon and software engineering degrees don't learn about security. I definitely didn't when I was doing my undergrad ComfyCon. And the thing about security issues, especially because of that, is that a lot of them are what's called unknown. So those are the ones where people don't even know that there's a problem that they don't know about, if you follow me. So it's that they're unaware at all that it's an issue, so they can't even try to find out about it or anything like that. And those are most dangerous because no one knows to do anything about them. So if you get developers some training, just even a little bit, will go a long way to get them to be at the point where they say, oh, hang on, I've seen a few examples of X, this might be a potential SQL injection thing here, or maybe we're going to have some cross-site scripting we're introducing if we do this. And you might say, I don't know what the fix for this is. I don't know what the correct way to do this is. But now I know this just has the look of being not right. So I'm going to go find the person in the organization who is the supposed expert, or I'm going to go even just read online a bit more. And to the point being that it can help them learn to spot these issues and find the appropriate help for them, even if they can't fix themselves. And you don't want to train everybody to be the security guru because, I mean, there's just too much to learn. They need to know other stuff as well, and people don't have enough time. And once you learn enough, some of the stuff will start falling on your head. But if you get it to the point where they have just a bit of awareness, it can make them a lot better in figuring out that making things known unknowns where they say, oh, hang on, this looks like an issue. I don't know the fix. I'll go get help. And you don't even need to do all that much to make it go a long way. Right. So those are sort of my top 5 suggestions today. I'm going to go on back to one more thing. So my original prediction was that the issue for Optus was that it was a production endpoint that someone had momentarily exposed inappropriately. Turned out probably that wasn't the case. There were suggestions eventually that it was actually a test endpoint that was just out online for everybody to access with no requirements on it. In fact, I was eventually told that yes, it definitely was the case. But somehow that test endpoint was using production data. I don't know if it was connected to production database or being preloaded somehow with production data, but it was real customer data behind a test endpoint. And so probably what had happened was people have said, oh, it's just a test endpoint. We don't need to bother with securing it. But because it had actual customer data, that customer data went out because it wasn't secured. And, that was a bad time for everybody. Right. So the point is that all your environments, production environments, unless they're definitely testing environments, and it's pretty unusual for things to be definitely testing environments, So you can only say it's a test environment if there's absolutely no sensitive data, no customer, employee, personal identifiable information, any of that sort of thing on there. If it's completely unused and inaccessible, definitely unused and preferably inaccessible by anyone who isn't involved directly in the development and testing process. And of course, there shouldn't be any ability for any changes made in it to be propagated back out of it somehow, which you'd think is obvious, but you never know. You don't want it to be that someone can get in and, they create a user like customer account and then 2 days later it comes back they get in, somehow change things to make themselves an administrator in the database, and then suddenly next thing you know, 2 days later an admin. And you probably actually want to reset the state every so often for various reasons. So basically, if there's any sensitive data involved, and if anybody not directly involved in the testing process is going to notice if the environment disappears, it's not a testing environment. I mean, if marketing or finance say are somehow depending on a test environment for some business process, then that's a production environment whether you like it or not. And if it's not a testing environment, then all normal security measures are absolutely mandatory, because who knows what can go wrong. Right, so to wrap up, I think one more time, basically back in September of 2022, the data of some millions of Optus customers, I heard varying numbers. I think the final number set it on to about 2.1 million, which is still like almost 10% of the Australian population at the time. Not great. About 2.1 million customers' data was leaked, accessed by someone. 10,000 records of it was leaked. And apparently, it was scraped from an Optus API endpoint that just had no authorization requirements on it whatsoever. And in the end, they were lucky that most of it wasn't leaked, but it was still pretty bad in terms of money and reputation cost to them. And another point I want to emphasize with all this, of course, is that when you get a situation like this and you're responding to it, and once you're done responding to it and later on, don't sit around trying to blame someone and say, oh well, it was security's fault, or it was the developer's fault, or it was the tester's fault for not finding it, or anything like that. Just don't do that. Focus on what the problem was and how to resolve it and how to make sure that it doesn't happen again. If you have policies that say don't do blah, but there's not being enforced, then look at how you can start enforcing them, that sort of thing. Because trying to find someone to blame, it's sort of closing the gate after the horse is bolted or something like that. What you want to do is actually basically try to figure out how to avoid it happening to you in the future. And so all this, to me, it suggested that basically probably Optus didn't have a fantastic setup in place at the time. And to me, that's something that if anyone's to be blamed for it, it'd be management, not the interns or the new developers or whatever, because they're the ones who are actually responsible for making sure that the system setup is correct. Right, so to quickly recap those 5 points that I made. So the best thing you can do is deny by default. If things aren't all basically unless people have explicitly said to make an API accessible to everyone, it's not accessible to anyone. And if people haven't gone through all the correct processes to get their authorization, then they get rejected. There's no, it's slightly tricky for our customers, so we'll just make sure it works anyway, because then it's open to everyone. Do get code reviews done, which works especially great when you've got a deny by default. So when people have to expose endpoints have to be explicitly marked as that, and people can look at it and say, well, hang on. And developers can look at things and say, this seems a bit funny. Don't make changes in production, because that just opens a whole can of worms where either fixes don't end up getting propagated back into your code base, and next time you do a deploy, you've got the same problem back in production again, or the other way around, where something gets into a funny state because someone was mucking around trying to fix the problem, and then that funny state hangs around and problems hang around. So basically just don't do that at all possible. Instead, use deployment from continuous deployment systems. Do some control validation or automated exposure testing, where you just have a thing sit there and ping endpoints and check the response codes, and it can tell you reasonably quickly if something's allowing in any unauthorized user when it shouldn't be, as long as it's set up right. And there's lots of ways to do that. And of course, get your developers some security training. Send them to ComfyCon, send them to another local conference. Can be a great place to start. Just getting them that bit more awareness of security issues, especially like the top 10, top 10, and that sort of thing. They don't need necessarily to know all the details, how to fix it themselves. But if they know how to spot something that looks funny, they'll learn to go get help for it, and it's going to be a lot better. Of course, there's no one single silver bullet to stop all potential breaches. You really need to try to use a mixture of things. But all of these ones here are pretty solid. They're implemented by different people, but they're all good, and most of them aren't really that expensive or going to have like a big impact on performance or anything. In fact, some of them, I would argue, are actually going to make things more robust. So basically, do at least these. And lastly, of course, it came out that probably this whole thing happened because there was real customer data on a test environment somehow or another. I don't quite know how, but basically, you should never have a test environment with real customer data that isn't treated like a production environment, because if it's got customer data in it, it's a production environment. So always assume it's production unless you're absolutely sure. So that's basically denied by default, again, if you think about it. And the only times you can ignore this advice and not secure a test environment is if it's really a test environment where there's no sensitive data whatsoever available from it. Changes in it can't get out of it. And nobody outside of development and testing actually ever uses it. Preferably nobody even knows it's there, but I'm sure they might find it. But if it's just some completely uninteresting thing, it's not too much of an issue. But yeah, if it's even just another internal group uses your test environment for some business purpose, then that's a production environment. So avoid that. So to sum up, remember, if in doubt, just say no. So deny by default. And unfortunately, you can't really see this. It actually kind of runs no, it's Simpsons wrong, but that's another story. Yeah, so basically, if there's one thing you remember from all this, it's deny by default, because that's going to save you a whole lot of trouble in the future. The end.
Thank you so much for that. I've personally found that being a security person, also being able to talk in the language of a dev, to be really powerful. I had a argument at work recently about, we don't want to. So I was going to mandate security testing on the main branch, and it's like, oh, well, we might not put security in straight away. I'm like, okay, that's fine. Whenever you merge into the main branch, we're going to test it for security. And, rightly or wrongly, whatever. But the fact that you're able to talk in that language, that you're able to understand the developer, is quite a powerful thing as well. So I think a lot of people say, oh, developers need to have security training. I think it's also a fair comment that sometimes security people need to understand what the developer's doing as well.
That could be true. I mean, I'm definitely a developer, not a security person. So I at work, because we're a large telco. Well, actually, we're the third largest of three in New Zealand, basically, of like the ones that actually have their own infrastructure. But that's still like well over 1,000 people, and we've got a proper security team. And I talk to them, but I don't know how to do their jobs. I don't think most of them know how to do dev. But I think that you're right. Definitely, you need to know a little bit about each other's stuff, at least enough that when they say something to you, you'd understand, or that you've got a happy enough place, I suppose you could say. And then it worked out, because you're talking about psychological safety, just somewhere where if you don't understand something, it's fine for you to say, I'm not following what you're saying. Can you please explain that some more? Because, I mean, I guarantee you that there's plenty of security stuff they say that I just have no clue what they're talking about. But if you're allowed to say, actually, I'm not following, please explain, then, you get on the same page. And in my experience, 99.9% of the time, issues are just because people, either they don't have a common understanding, or they have like different assumptions, and people don't understand that they've got different assumptions. So they come to different conclusions, because each one of on each side it follows logically. It's just they understood something different to begin with. So yeah, it's if you've got developers, you do want them talking to each other, I think is the motto, the message there.
Oh, fantastic.
I think I have that unpopular opinion, which kind of leads on from this. When, because people, how do I get into cyber? I kind of go learn IT or be a developer. You know what I mean? Because I think it's the same thing, right? Regardless of whether it's a developer knowing security or security people knowing development, if you've been a developer and then you move into a more security focused role, it is going to be much easier for you than someone who's in security and knows a little bit about development.
Yeah.
And it holds true for every kind of vertical, right? And people ask me, with digital forensics, I kind of feel like if you haven't pulled apart computers and, broken them and, all of those things, then how can you then come up with hypotheses and stuff like that? So, I 100% think that, getting into security from a career of doing some other kind of technical job is a really good pathway. And to be honest, there is a lot of jobs in IT, and it's all cyber. Like, getting into cyber, it's not just cybersecurity. It is your IT, your network engineers, software engineering, all of that kind of stuff. Anyway, rant over.
Straight talking to people. Straight talking to people. Didn't you start in help desk? Remembering that rightly? Or
I did.
I'm making that up?
I did.
Yeah.
In help desk.
Well, there you go. Because people say, I don't have the traditional pathway into cybersecurity. I think to myself,
yeah, no degree. I started doing tech support for an ISP. So
that seems to be the closest to a traditional way into cyber from what I can see.
Yeah.
So,
yeah.
I just when people say, I don't have the traditional background, I'm like, I don't know what you mean by traditional because the pathways are so varied that people have taken.
Yeah.
Awesome. Thank you very much for that, James. It was a great talk and obviously complimented some of our learners as well.